So we know quadratic functions typically give us parabolas, and if we look at the parts that we know that bottom point here in this case we call the vertex. It's like the center, it's where it changes direction, so it's an important point. It's where we want to start if we want to get to graphing the parabola. We know from the vertex we also get the axis of symmetry, which is that line that's going to cut it in half, and so that may be something we can use as we look to write the equation. And we also get this point over here, and that's going to be our y-intercept, and that's where the equation hits the y-axis. This will be a nice point whenever we look at finding the graphs as well. Now we need all of this, or we're going to use all of this, as we look at the first equation we use to graph quadratic functions, which should look familiar because it's what we spent some time factoring and solving in the last chapter, and that's y equals ax squared plus bx plus c. Now first, let's think how we can solve for it. So we actually are given the axis of symmetry for this equation is x equals negative b over 2a. So whatever value we have for the coefficient on b and whatever we have for the value for a, we're going to plug those in, and it's going to give us the axis of symmetry. Now once we have the axis of symmetry, we're going to go about finding the vertex for the graph. Now the vertex we know is the xy value, and we talked about in the previous part that the axis of symmetry and the vertex are the same value, so that's negative b over 2a for the x value. The y value, we'll get back to that. The other thing we can also find, like I mentioned already, is the y-intercept. The y-intercept, what you're going to do here is you're going to let x equal 0 and solve for y. And we'll see as we start looking at these, this is a nice point to get, and it's going to help us in solving them. So really we need that other point for the vertex. Let's first look at an example before we figure where we're going to go there. So we have this equation. Let's get a graph down. We're going to go with a y equals negative x squared plus 4x minus 2. So our b value is 4, our a value is negative 1. So our axis of symmetry is x equals negative 4 over 2 times negative 1, because that was, again, negative b over 2a. So we get here negative 4 over negative 2, which comes out to be positive 2. So that means on our graph, we could draw a little dotted line through 2. So I don't know yet where the vertex is, I just know it's going to be on that line. Now I also mentioned earlier we could do the y-intercept. If I let x equal 0, basically drop anything with x's, I get 0 squared plus 4 times 0 minus 2. Y equals negative 2 is our y-intercept. So I know it's going to go through that point. I know the vertex is on the axis of symmetry. I also know that since there's a negative out in front, that my parabola is going to point down. So I could even start to guess where my points would go, because I know they have to be above the y-intercept. What I'm actually going to do is I'm going to plug in this 2 into my equation to find what the value is at 2. So y equals a negative, we're going to go 2 squared plus 4 times 2 minus 2. I get a negative 4 plus 8 minus 2 gives me a positive 2. So that means my vertex is at the coordinate 2, 2, which fits because we said our graph should point down. It's going to go down through the y-intercept. So that's one side of it. How we can find the other side is I could sit and I could plug in points for 3 or 4, but we also talked about how it's symmetrical. So if I went over 2 units to get the y-intercept point, I could go on the opposite side 2 units over and use that symmetry to match it up and draw my parabola. Okay, so let's go back here to our vertex, and we are going to substitute the x into y from the axis of symmetry. That's how I'm going to find my vertex. So negative b over 2a, then I substitute whatever that comes out to be into y for my axis of symmetry, whatever value I'm getting there, that's going to give me my vertex. So let's look at another one. Let's go y equals negative 2x squared plus 8x plus 9. And what we should get really good at is, as we look at these problems, we should just start to figure out what we know about the parabola, where it's going to go. The negative out in front tells me it's going to face down. The 2, we talked about, the bigger the number out in front, the skinnier it's going to be. So I actually think it's going to be more of a skinnier parabola as opposed to being wider. The 9, if we let all the x's be 0, we know the y-intercept is equal to 9. So what we already know in our graph, and we haven't even figured out the vertex, we know our y-intercept is going to be at 9, and it's going to be pointing down, and it's going to be 2x. Well, if it's pointing down, that means I'm already off my screen. So let's just scale it down. We'll put 9 right here. So I know already it's going to be going down in this general direction. I just got to figure out where that vertex is. So start with the vertex. I need to find the axis of symmetry. So we do x equals negative b over 2a. I do negative 8 over 2 times negative 2. That gives me negative 8 over negative 4, which is just 2. So I have an axis of symmetry at 2. I now plug that in to my equation to find the point that it works at 2 on the axis of symmetry. So that's negative 2 times 2 squared plus 8 times 2 plus 9. This becomes 4 times negative 2, or negative 8, plus 16 plus 9. Looks like we have 25 minus 8 is negative, right, positive 17. So right about this point is where we hit. On the other side, we graph it. Let's label at 2, 17 was our vertex. Let's do another one. We'll go y equals 2x squared minus 6x plus 1. It's positive, so we know it opens up. It's 2, so we actually know it's going to be skinnier opening up. A 1 tells us our y-intercept is 1. So let's find the axis of symmetry. We're going to do x equals negative b over 2a. That's a negative of negative 6 over 2 times 2. Positive 6 over 4, which is 3 over 2. We plug that in to our equation. We get 2 times 3 over 2 squared minus 6 times 3 over 2 plus 1. Now, 3 over 2 squared we should know is 9 over 4. I then multiply the 9 by 2, and I can just make this 18 over 4. Bring down the next, I have it's 6 and 3 is 18 over 2, which I could make into 9, but why don't I just bring that down as 18 over 2. And of course we have the 1, just tags along as 1. But now on this bottom row, let's change them so they all have the like denominator. I can make 18 over 4 into 9 over 2. I could make the 1 into 2 over 2. So really we're looking at what do we get left with over 2. 9 minus 18 is negative 9, plus 2 is negative 7. So negative 7 over 2 tells us our vertex is 3 over 2, negative 7 over 2. So let's go to a graph here. We know y-intercept is at 1. Now, vertex at 3 over 2, negative 7 over 2. 3 over 2 is 1.5, so we're going to go over 1.5. And then negative 7 over 2 is a 3.5, negative 3.5. So we'll go down. Looks like our vertex is right there. And it opens up through our point. We'll go off the axis of symmetry. If we look, it's 1.5 away from the y-axis, so we'll go another 1.5 on the other side, plot it, we get matching points, and we sketch our parabola. Last one to look here is when we have a vertical motion problem. So let's say we have a object we're going to fire up. Let's say we have a t-shirt cannon, and we're going to shoot a t-shirt at a basketball game. It goes up, it comes down. And we're going to first say that they started 5 feet is where it left from, and it's going to land, and someone's going to catch it 5 feet in the air. So it's like they're catching it in their arms 5 feet off the ground. So what we want to first find out is what is the maximum height that it could go. So if we want to clear something, or if we have to make sure it has proper clearance within the facility, what's the maximum height it could go? So we start with the negative 16x squared we looked at before, and this relates to falling objects, because once we start shooting it out of a cannon, it's going to start slowing down because eventually it falls back down. What we also get in this problem is that it goes off at a height of 64 feet per second is its initial velocity up. So 64 feet per second. So that's about the distance, if you're thinking from a pitcher's mound to home plate. That's the distance it would travel in a second. So it starts off moving up pretty fast. And that's again vertical. It's not a horizontal motion, but vertical motion. Now we're going to put that into our formula. Our equation we have. So we have the amount that it's slowing down, the negative 16x squared, which is eventually going to bring it back down, plus the 64x, and then plus 5. Now, if we wanted to look at first figuring out when it reaches its maximum height, we're kind of looking for its vertex. So to find the vertex, we're going to start with the axis of symmetry. So the axis of symmetry here is going to be x equals negative 64 over 2 times negative 16. This gives us negative 64 over negative 32, which comes out to be 2. We then take that and plug it into our equation. Negative 16 times 2 squared plus 64 times 2 plus 5. So let's see, we have 2 squared times 16 gives us negative 64. 64 times 2 is 128. So 128 and minus the 64 is going to leave us with 64, plus 5, we get a height of 69, or I guess a vertex point of 69. So what does this mean? This means if we shot it up in the air, it would reach a maximum height of 64 feet, or 69 feet, sorry, 69 feet. What is the 2? The 2 is how long it takes to get to that maximum height. So in 2 seconds, that thing has already gone up 69 feet in the air. It's reached its maximum height, it starts coming back down, and then the question then becomes, how long does it take to get to this person standing there? Well, if it took 2 seconds to get to its maximum height, it would take another 2 seconds to get back down to that point at 5 feet, because really it's the same point that I started with for that person to catch their t-shirt from the t-shirt cannon. Now, let's look at another way we could write the equation. So this is going to be vertex form, we're going to call it. And you're going to be able to recognize the difference in this form from the other one, just in how it's written. So let's start with f of x equals ax minus h squared plus k. Now let's start with what's the same here. I still have the a, and the a is still going to tell us up or down, whether it's positive or negative, and it's still going to help us determine width. So the bigger the value, the skinnier it is, the wider the value, or the smaller the value, the wider it is. What we now get, though, is the vertex are going to be the coordinates h, k. So we take h out, we take k out, and we get those parts. Now it's not as easy as just taking them out, because you have to notice it's x minus h. So what we're actually going to do is change the sign when we take the h out to get our vertex. What this will let us do is immediately know the vertex and immediately know which way it's facing. Now we can also add here that the y-intercept, we could still find it, and the y-intercept is you're just going to let x equal 0 and solve for y. But it's not going to be as direct as the last one we looked at. So let's shrink this down, look at a couple of them. If I started with, let's go y equals x minus 4 squared minus 3. If I take the negative 4 out, make it positive, bring negative 3 down, this tells me my vertex is 4, negative 3. Meaning on my parabola, I would go over 4, down 3, it would open up. If I had y equals negative x minus 2 squared plus 1, I take the negative 2 out and make it positive, bring the 1 down, keep that the same sign. Our vertex is 2, 1. We know since there's a negative here, it's going to be going down. So I went over 2, up 1. Now if I wanted to find my y-intercept, I'm going to let the x's be 0, so that would be y equals negative 0 minus 2 squared plus 1, which would be negative 4 plus 1, and we get negative 3. So it would hit down here at negative 3. And we'd have our parabola. If we did another one, let's go a y equals 2x minus 3 squared. So our vertex, we take the opposite of the 3, because always for the x you take the opposite, we get positive 3. But there's no value here. Well, if there's no value there, it's just like adding 0. We just call it 3, 0. So this now becomes a parabola with the vertex at 3, 0. Just went out 3, and it's going to be opening up because we have a positive 2, and we have it there. Let's go and compare these two. Let's say I have negative 3 x minus 6 squared plus 4, and then we go y equals 1/3 x minus 6 squared minus 2. So let's start with what's the same. Well, I see these negative 6's. What the negative 6's means is that not only the vertex will have the same x value, but it also means the axis of symmetry is the same. So both of them have the same axis of symmetry at when x is 6. Okay, what's different is the one on the left looks like it's going to open down, and it's going to be a 3, so it's actually going to be down and skinnier. Whereas the one on the right is a 1/3, it's going to be up and wider. The one on the left has a vertex at 6, 4, where the one on the right is going to have a vertex at 6, -2. So if we draw and compare these two, we go 6 over, 4 up to get to our one on the left, and that's opening down. And then for the one on the right, we go 6 over 2 down, and that's opening up. We have them here. Now last thing we look through, let's look at the y-intercepts. So for the one on the left, it's going to be a -3 times 6 squared, well, -6 squared. It's going to be the same thing, -6 squared plus 4. We get -3 times 36 plus 4. For 36 times 3, we get 108, so that's actually a -104 it comes out to be. So that means it's going to be quite a ways down before it actually hits the y-axis. For the one on the right, we were to go y equals 1/3 of -6 squared minus 2. That's going to be 1/3 of 36 minus 2. 1/3 of 36 is 12. So that's actually going to hit the y-axis at 10. So maybe it continues up, hits there at 10 as our y-intercept.